Alright folks, today's lesson we're looking at the introduction to limits. Limits being one of the four main portions of this calculus course, and arguably the most important because the idea of limits is what leads to everything else that can occur in the calculus world. So let's just get right into it. What is a limit? A limit is the value that the graph of a function approaches at a point. And the big word, it's here in all caps, is the word approaches. And maybe a good way to try to think through this is kind of ask yourself in this way. As x approaches, if I can spell correctly, as x approaches something, then f of x, the function, approaches, I did it twice, what? That's what we're going to try to figure out. So as x approaches some value, then the function f of x approaches some value. So really we should say this is the function value or the y value that the graph of a function approaches at a specific point, that point being at what x value. So when we find limits, we're going to look at these throughout. The easiest way is graphically, but you don't always have a graph. So graphically is going to be definitely the easiest, but probably only happens about 20% of the time in terms of showing up on an AP exam. Using a table, honestly, it's good to look at, but it very rarely will pop up in the real world just because it's very cumbersome. You'll see that here in a couple of days. Analytically is the big one. This is around 80% of the time that you will have to solve something analytically, which just means we're going to have to use some sort of algebra to be able to solve it. So we'll get to those going on, but first let's just kind of look at what this idea of a limit is. So we have a graph dealing with this function right here. Here's what the graph looks like. And what they're asking you to find is this thing right here. So the way you read this right here, it's read as LIM just means the limit. So you read that as the limit. This part right here, x, and that's an arrow to 1. So that means as x approaches 1, and this can be any number whatsoever, you'll see here in a second. So as x approaches 1, and then it gives you the function at the end. So I say of f of x. So the way you read that fully, the limit as x approaches 1 of f of x, that's what that means. So what we do is we find x equals 1 here on this graph. So as my function gets closer to 1, so what I mean is, here's a value that's to the left of 1. I'm going to go and get as close as I can until I get to 1. I'm kind of following the path. Same thing here from the right-hand side. I'm starting to the right of x equals 1 and going back until I get close to it. What is the function value that I'm approaching as I get close to x equals 1? You can kind of see here, pretty easy to see, that that limit as x approaches 1 of f of x is the y value of 3. Even though it's an empty hole, the function value doesn't exist. That's fine. We don't care about the function value. We want the limit value. So the answer to this is 3. Just to look at another one. Let's say the limit as x approaches 0. And instead of f of x, just so you can see, it could be written fully out in that notation as well. So the limit as x approaches 0 of this function. So what that means, again, is I'm going to go, well, here's x equals 0. As I approach from both sides of 0 on the x axis, what y value does it look like I'm hitting? And I'm hitting right there, actually, at a value of 1, a function value, a y value of 1. Let's take a look here at another graph. The limit as x approaches 0. So this one kind of works out nicely as well, because I'm just going to approach x equals 0 from both sides. And when I do that, I look at the y value I'm approaching, which is 2. So there's another instance of showing how you can have it just with the function written out rather than of f of x. This one right here, find the limit as x approaches 2 of this graph. Okay, so here's where it can get a little bit confusing, because as I approach an x value of 2, I follow this graph and I follow this side of the graph, what y value am I approaching? Well, the y value looks like it should be right here, 1, 2, 3 up, so it should be 3. Even though the dot is down here at 0, that doesn't matter. All I care about is what I'm approaching as I get really, really close to 2. Remember, we'd be looking at like, 1.999 from that last video, or maybe 2.001. That's what we're talking about. Now, if they just ask straight up, what is f of 2? Well, that's not looking at what we're approaching. We're looking what is the function exactly, and that's why that dot being down there is big. That's why the answer is 0. So you can see here, limit and function value do not necessarily always equal the same thing. We'll look at that actually here in 1 second. With this problem here, though, the limit as x approaches 0 of this function, well, here's x equals 0. As I approach from the left, I'm approaching a y value of, it looks like, -1. As I approach from the right, I am approaching a y value of +1. So what am I approaching as I approach 0? Is it -1? Is it +1? Is it both? Actually, it's neither. This does not exist. And the way you look at that, basically, if you don't have approaching from both sides, approaching the same function value, the same y value, then you can't have a limit existing. Now, this does give us the idea, though, of something that we can look at. I'm definitely approaching something from the left. I'm definitely approaching something from the right, even though they're not the same. That's the idea of one-sided limits, and we'll get into that a little bit more here in the next lesson about approaching from the left versus approaching from the right. But if it's not the same from both sides, then we have to say the limit does not exist and go straight mean girls on this. Okay, one last set of problems. I might even recommend pausing the video real quick, see if you can figure these out, and make sure you pay attention first, whether you're asking for a limit or whether it's asking for a function value. Pause it, give it a try first, and then come back and see how you do with your answers. All right, let's see how you did. Remember, it's not bad to make mistakes on these, but it's good to try them on your own first. Make sure you do so. So this first one, limit as you approach 1. So limit, approaching. So here's x equals 1 as I approach from the left. I approach from the right. It looks like I'm approaching the same y value. That's good. So that is -1. This next problem, f of -3. So I don't care what I'm approaching. I just want to know where is the function at x equals -3. And we have a single dot here at 0. So that's perfect right there at that dot of 0. This one, limit as x approaches 2. So here's x equals 2. It's a limit. I'm going to kind of draw where am I going. It looks like I'm approaching the same from the left and right. Here at this open circle, I have a y value of 2. Notice it didn't say f of 2. That's this next problem. F of 2 wants to know what the actual function value is at 2. It's not the open circle, it's the closed circle up there at y equals 3. F of 1 kind of goes back to what we had here. The limit was approaching -1, but we want the function this time. Where is the function? There is no function. So this function value does not exist, DNE. F of -2. So we're going to look and find where -2 is on the graph and where's the function. Well, there's no dot, but we don't need a dot. It's a solid line. We still have the function occurring right here at that point. It's like there's a dot there at a y value of 2. If they ask, I don't think it does, if it asks the limit as x approached -2 of f of x, well, it's also approaching at that point too. So here's a case where the function and the limit equal the exact same thing. I'm both approaching 2 from the left and the right. Last couple here, limit as I'm approaching 0. Actually, this looks the same as f of 0, because as I approach 0 from the left and the right, I'm approaching the exact same y value of -2. And then my last problem here, as we approach -3, we already did the function value here at -3, but if I approach from both sides, the y value I'm approaching is 1. And this final question is kind of working backwards. Give an interpretation of what this statement means. Well, we're just going to read it off first, and we're going to say the limit as x approaches 7 of the function f of x is 10. So limit as x approaches 7 of f of x equals 10. Now what does that mean? So as x goes to 7, the function value, the y value, is going towards 10. Now, does that mean that f of 7 equals 10? Well, it may be, but we don't know that for sure. All we know is that as we're getting closer to an x value of 7, we're getting closer to a y value of 10. Good work. That's the section on the introduction to limits, and we're off and running.